In this video, we'll do some examples of continuity of a function at some point. So this is the definition of continuity. That is, the function is continuous at this point when these two conditions hold. The first one is that f of a should be defined. That means when I plug this value into the given function, I should get a defined value. And the second one is limit f of x when x is approaching to a must exist and it should be equal to f of a. That means these two values should be same. I have explained the meaning of this definition in my previous video, so if you want to go through that, I have given the link under the description of this video. Now let's do the examples. The first one is f of x is given by x plus 1, and we have to check if the function is continuous when x is equal to 2. Alright, check if the function f is continuous at x is equal to 2. That means to check the continuity of this function, I have to check these two conditions. So first of all, I'll find if the limit exists of this function at the point 2, because we have to check the continuity at this point 2. So limit x approaches to 2, the function is given by x plus 1. Now if you're familiar with limits, you'll know how to solve this limit, and we can solve it by direct substitution method. So I get 2 plus 1, which is equal to 3. Now I have to check that if f of a is defined or not. Now here f of a is f of 2, and f of 2 will be equal to, I just have to put this value 2 at the place of x in this function. So I get 2 plus 1, which is equal to 3 here. So now these two values are equal. That means the limit f of x when x is approaching to 2 is equal to f of 2. That is, limit x approaches to 2, f of x is equal to f of 2. That means by this definition, the given function, this is continuous at the point x is equal to 2. Now if you see it graphically, let me make the graph. This is the point 1, 2, 3, 1, 2, 3. The graph of this function looks like this, as it's a straight line. Y is equal to x plus 1 is a straight line. Now here we see at the point 2, because we have to check the continuity at 2. At this point, the function is defined and the value is 3. If we check the limit, when x is approaching to 2 from the left side, the function is approaching to 3 from the left side. And when x is approaching to 2 from the right side, the function is approaching to 3 from the right side. That means both the conditions hold. And this, we can see that this is a line, continuous line. So by this definition, we proved that this function is this function is continuous at the point x equals to 2. You don't need to draw the graph if you are simply asked to check the continuity of the function at the point. So let's do one more example. The function we are given is x square minus 1 divided by x minus 1. And we have to check the continuity at the point 1. So what do? We have to check these two conditions. So first of all, I'll find the limit at the point 1. So it is equal to limit x approaches to 1. The function is given by x square minus 1 divided by x minus 1. Now here I cannot use the direct substitution method. As I plug this value into the function, I'll get 0 over 0 form. So I have to check if I can simplify this function and get something else out of it. So now I can make the factors of this term. x minus 1, x plus 1. In denominator it's x minus 1. Now here we know when we are solving the limit, when x is approaching to 1, that means x is just approaching to 1 from both the side. X is not equal to 1 when we write x approaches to 1. So here, because x is not equal to 1, so we can cancel out these terms. So what do we get? Limit x approaches to 1, x plus 1. So if I solve it, I get 2. Now I have to find f of a. That means f of 1. So f of 1, for that I have to put 1 at the place of x in this function. So I get x square minus 1 over 1 minus 1, which is equal to 1 minus 1 over 1 minus 1, which is equal to 0 over 0 form, which is undefined. So by this definition, the first condition does not hold and the second condition holds. So if any one of these two conditions does not hold, then the function will be discontinuous. That means the function is not continuous at the point we are checking. So this function is not continuous at the point x is equal to 1, or I can write discontinuous. Discontinuous. Now let's see how does it look like on a graph. This is x-axis, y-axis, 1, 2, 3. So the graph of this function looks like you can make this graph either by finding some values of the function by putting some random values of x in the function and plotting it in this graph, or you can just use a graphic calculator to find this graph. Here we see this function has a little hole on this curve, or this curve is a line, so on this line. So this is f of x. So that means this function is not continuous if I say it graphically at the point A. Now from here I notice that this function is just not continuous at this point, but at other points if I have to check, this function is continuous. So if you check the continuity of the same function at different points, this function will be continuous. But at x equals to 1, this function is not continuous.